Hi there, and welcome to this lesson. In this lesson, we'll be learning about number systems, okay? We'll be learning about the bases of number systems, so number bases. Now, as the lesson progresses, if you have any issues at all, anything you don't understand, be sure to contact your tutor who would be more than happy to help. Okay, let's jump right into the lesson. So number systems, the basis of number systems. Now, what exactly are number systems? Now, number systems refer to the number of symbols used to represent numbers. Now, what exactly is this about? Basically, we have different ways we count numbers, okay? Basically, the most popular one being the decimal system, called the decimal system or base 10, okay? Different ways of counting numbers, but the one that you're used to is decimal system, okay? And in the decimal system, you make use of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now you count from after 9, you have 10, 11, 12, 13, 14, 15. You can keep doing this up until 1 million, 10 million. But then something you need to know is that when you're counting using decimal system, every number you form, you make use of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. For example, if you have a number like 579, you've made use of the digits 5, 7, and 9. If you have 10,512, you've made use of the digits 1, 0, and 2 to form. So basically, every number you form using the regular counting system, the decimal system, you form using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, I'm going to introduce you to a different system of counting numbers, okay? I'm going to introduce you to the binary system, okay? Now, the binary system is very important in computers. We use the binary system in computers. It's not the usual counting system you're used to, okay? The normal one is base 10. Now, this is base 2. Now, what is base 2? Now, base 2 makes use of just 0 and 1. So every number you can form, when you're counting in base 2, you can only use the numbers 0 and 1. So basically, you start with 0, the next number is 1, okay? After 1, you can't have 2, you can't have 3, you can't form any number with numbers apart from 0 and 1. After 1, you have 10. After 10, you have 11. After 11, you have 100. But let's get through. And basically, another system for counting numbers, we have base 5, and if you're counting in base 5, you can only form numbers with 0, 1, 2, 3, and 4. So basically, if you're counting 0, 1, 2, 3, 4, after 4 you can't have 5, okay? You can't have 5. After 4, the next number is 10, okay? And after 10, you have 11. After 11, you have 12, and so on. But generally, one thing you need to note, if you're counting in base 10, okay, you can form numbers from 0 to 9. If you're counting in base 2, you can form from 0 to 1. If you're counting in base 5, you can form from 0 to 4. If you're counting in base 8, you can form numbers with numbers from 0 to 7. Okay, it's pretty much that simple, that's straightforward. Okay, so let's count in base 10. And counting in base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, 9 and 10. And now let's count in base 5. Now, for base 5, we have 0, 1, 2, 3, 4. Now, after 4, we can't form any numbers because the next number is 5 and we don't have 5 in base 5. So after 4, we have 10, 11, 12, 13, 14. There's no 15 because we can't form with 5. The next number is 20. Okay, now what about base 2? Base 2 is very interesting. Now, this is base 2. Base 2, you count 0, 1. You can't do 2, you can't do 3, you can't do 4. The next number is 10. Then 11, you can't do 12, you can't do 13. The next number is 100, 101, 110, 111, 1000, 1001, 1010. And basically, you notice you can only form numbers with 0 and 1. So that's pretty much what you need to know about number bases. Now let's learn about comparing number bases. Okay, so we have if you count numbers in base 10, okay, basically your regular numbers, so you have 0 up until 25 here, all right, and then you count in base 5, so 0, 1, 2, 3, 4, 10, 11, 12, and then you have that up until 100, and then you count in base 2. This basically this is what you have 0, 1, 10, 11, 100, 101, 110, and basically if you get used to this with some practice, okay. But here's what we want to do. We want to compare number bases, okay, and what we want to do is we want to learn to convert from one base to another, okay. For example, if you have 9, okay, and you 9 in base 10, you could be asked to convert 9 in base 10 to a number in base 5. Now I tell you 9 in base 5, 9 in base 10 to a number in base 5 is 14, and 9 in base 10 to a number in base 2 is 1001. Okay, now let's do an example. Okay, convert 17 base 10 to base 5. Okay, now if you look on our table there, you'd find that 17 base 10 to base 5 is 32. Okay, but some you won't always have this table. Okay, so let's say you're not given this table. How would you go ahead with converting a number in base 10 to base 5? Here's what you do. Okay, now watch closely. You draw this table, okay, and you put 17, and what you're going to do, you're converting 17 base 10 to base 5. What you're going to do is you're going to divide by 5. Okay, we divide by 5, and we say 17 divided by 5. 17 divided by 5, we can't divide 17 by 5. What we have is we have 3 remainder 2. Okay, we can't divide 17 by 5. We can divide 15 by 5. 15 divided by 5 is 3. So 17 divided by 5, 3 remainder 2. Now we have 3 remainder 2. We're going to divide again. Okay, we're going to divide again, and basically we divide by 5 again. All right, and at this point we really can't divide 3 by 5, but then we just go 3 divided by 5. We'll write this as 0 remainder 3. Okay, you just write 0 and put the 3, because 3 is less than 5, so we really can't divide 3 by 5, but then we write it down as 0 remainder 3. Now you get to the end only when you've gotten to the point 0. Okay, this will get clearer shortly. And then what you do is you look at the remainder, and you read the remainder from the bottom to the top. Okay, and what you have is you have 3, 2, 32. And if you look back at our table, you find that 17 in base 10 to base 5 is 32 in base 5, and this is how we write it: 32 base 5. It's very, very important learning how to convert from one base to another. Okay, so you have different counting systems. You can count in base 10, you can count in base 5, and sometimes you could be given a number in base 10, basically a number in the base 10 system, and you could be told to convert this to a number in the base 5 system. And what you do is you just divide by 5 and you take note of the remainder. So we start with 17. 17 divided by 5 is 3 remainder 2. Okay, now we can't divide 3 by 5, but we just go ahead and say 3 divided by 5 and write 0 remainder. We'll just put the 3 down. Okay, and when you read from the bottom to the top, you have 32 base 5. Let's do another one. So convert 5 base 10 to base 2, and if you look at our table, what we have is 5 and base 10 to base 2 is 101. Okay, we just draw our table, write 5, and what we're going to do now is we're going to be dividing by 2. Okay, so when we're converting to base 5, we divide it by 5. When we're converting to base 2, we're going to divide by 2. So dividing with 2, we have 5 divided by 2, it will give us 2 remainder 1. Okay, so basically when you divide 5 by, you can't divide 5 by 2, you can divide 4 by 2, but dividing 5 by 2 will give you 2 remainder 1. Okay, and then you divide 2 by 2, you get 2 can be divided by 2 without any remainder. So what you do is you write it down as 1. 2 divided by 2 is 1, remainder 0. Okay, there's no remainder, so you write it down as 0. And then 1 divided by 2, remember you don't stop till you get to 0. Your last number must be 0. Okay, so 1 divided by 2 would give you 0 remainder 1. Okay, you just write it down as 0 remainder 1. All right, and then again, we read from the bottom to the top, and basically what we have is 101 base 2. Simple, straightforward. Now let's do some examples. Example 1. Example 1 says convert 75 base 10 to base 2. Okay, so we have 75 in the decimal counting system, and we want to convert this to a number in the binary counting system. Okay, and then basically we just draw our table. Okay, I'll write 75, and we're going to be dividing 75 by 2 simply, and basically 75 divided by 2 would give me 37 remainder 1. We just keep dividing by 2. 37 divided by 2 would give me 18 remainder 1. 18 divided by 2 would give me 9 remainder 0. 18 can be divided perfectly by 2, so we have 9 remainder 0. 9 divided by 2 would give me 4 remainder 1. 4 divided by 2 would give me 2 remainder 0. 2 divided by 2 would give me 1 remainder 0. This is a really long one. And then 1 divided by 2 would give me 0 remainder 1. And again, we read from the bottom to the top. And basically, if you look at that, we have 1 0 0 1 0 1 1. Okay, so 1 0 0 1 0 1 1 base 2, and that is 75 in base 10 to base 2. 1 0 0 1 0 1 1. Okay, notice that all the numbers, the digits in base 2 are just 1 and 0, 1 and 0. So 1 0 0 1 0 1 1. Okay, now let's do one final example. Okay, and then we have convert 127 in base 10 to base 6. So we have 127, and we just divide by 6. Okay, so 127 divided by 6, what we have is we have 21 remainder 1. 21 divided by 6, we have 3 remainder 3. Okay, and 3 divided by 6, you just write it down. You can divide 3 by 6, you just write it down as 0 remainder 3. Remember, you only stop when you get to 0. And then you just read this from the bottom to the top, and what you have as your answer is 331 base 6. Simple, straightforward. And that would bring us to the end of this very simple lesson. And then yeah, go ahead now and solve the questions on the worksheet, and bye for now.